Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the problem number 104. The challenge name is maximum depth of binary tree, and for this particular challenge we have the function of max depth with the takes one parameter called the root, and the root parameter, it is possible that it's in a form of tree node class already described here, and either tree node or null. It is possible between tree node and null, and the expected output is in a form of number. Since we are using the language of TypeScript, if you want to use something else other than TypeScript, you can do it. I encourage you to do so. And for this class, we have the tree node class, which is the own value property in a form of number or integer, and we have left property that it is possible on another tree node or null, and the right property is also in the form of tree node or null. And for this constructor of the class tree node, we have three parameters, which is the value, it is possible to be undefined, and left property, and also the right property is also possible to be undefined. What is the value? The value property is the, let's say the bubble right here is called the tree node itself, and the value property, which is the tree right here, it is considered as a value. And the left property, it is also in a form of tree node represented by the another bubble, and this one is the left property from the tree node called the tree with the value of 3. And for this right property, we have another tree node of the value of 20, which is a value from the right property of tree node of the value of number. And for this 20, we have left and right property. The left, we have a bubble of value of 15, and this right property of 7 as the value, and we have null value from the 9, which is the left property and right property, since 9 doesn't have any tree node after the 9 branch, and that way 9 is considered the final branch from the tree. And for this particular challenge, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So for this example number 1 right here, we have 3 node with the value of 3, and we have the value of 9 and 20, and the output is 3. It's because the 3 right here takes 1 depth, and next one, which is 9, we have depth of 2, but this one we also have depth of 2, and the next one we have depth of 3, 20 and 15. And it is also possible that 3, 20 and 7, it is also with the depth of 3, so the maximum depth, which is output of 3. And we have the root of 1, null and 2. So the 1, null and 2 is in a form of just node 1 with the left property of null and the right property of 2 with the value of 2. Let me visualize this by using this. So using this Excalibur drawing, let me draw 1. Use the blue color 1. We have the arrow that points to the left. Since the left is null, then we have the right property, and we point the right property, we have the value of 2, and the left property is null and the right property is 2, and that way we have value of null and the right property is 2. So let us dismiss this part, null, and since it is null, then of course we not pointing anything other than the 2 with the 1. And the node is roughly visualized as this, and we have depth of 2. Why is it 2? It's because we have root that is considered value of 1, and since it's not null, then of course we count this by 1. And also the next one, the link one, which is the right property, which is 2 right here, we have the value of 2. Since it is not null, then of course we are returning another 1. Since 1 plus 1, since they are both linked, then of course we are returning the depth of 2. so hence the output is 2. And the possible constraints, we have the number of nodes in 3 in this range from 0 to the 10 with the power of 4. And the value property, it is possible to be minus 100 or negative 100 inclusive with the 100 positive. So for the second constraints, we don't have to worry about that one since we are only counting the depth of the 3 node or the linked list. So let us solve this out by using the example 1. So let's say 3 is also considered the node itself. Since it is not null, which is the root, then of course we are returning 1. So let's take 1 as the placeholder for the max depth of the counting the root itself. It is returning 1. And for the, we can add another check if it is null. If the root is null, then of course we can add an edge case check if the root is null using the exclamation mark with the variable name or the parameter name, which is root. Then of course we return 0. Why is it 0? Is because since we are using the recursive approach after this, if we happen to check the 9 property, which is the life property, and we recursively checks the left and right property of the 9, since after the 9 is null, then of course after the calling the function max depth, we have the if check, which is the edge case. We are returning 0 and returning to the 9, and the right property is also returning 0, and we go back to 9, which is 0 plus. They both have 0 value from the left and right from the 9 3 right here. Then the 9 itself has the value of 9. Then of course we have the depth of 1. Since we are comparing 0 and 0, which is equals to still 0 because it is the highest value between the two, then of course we are adding this by 1, which is the node itself of 9. So let me explain this by using the escalator drawing. We have the 3 right here. So we have 3 and we call this the root node, which is the parameter of the max depth function. We have 3 as our root. And we call the max depth to the left and right property using the max depth. Let me copy this part. The depth, we have max depth again. We call max depth on the root. Since we have root.left as our property, then we can of course take the root.left as the parameter of the recursive call of the max depth itself. And for the right one, we can call root.right. Since root right here, we have returning 1 as our value, as our placeholder value. Then of course the 3 itself, we have 1 as our returning value from the max depth of the 3 itself. And then we call max depth root.left and max depth root.right. And after we call the max depth root.left, if since 9 is not null and 20 is not null, since they are both not null or the value is there, is in a form of another 3 node on the branch from the 3 and 20 is from the branch of 3, then of course we returning another 1 as our value. We only returning 1. And then after the 9, we call another max depth. Let me copy this part using the max depth again of the root.left, and let me copy this part and paste root.left, and we call again max depth root.right, and we call both max depth function on the left node of the 9 and right node of the 9. Since the after the 9 we have null using this particular arrow, we have both null. Since it is null, then of course we are returning 0. Let me use 0 because it is null. It is already handled by the edge case from the if it is not root or it is null, then of course we are returning 0, and it is already get keep from here. then we are returning 0. And then we count this up 0 and 0. Before we count this up, we need to compare both 0 before returning back to the 9. So that way we can declare another let or constant. We can declare a let variable called the left node. We can call the max depth. Since max depth itself is returning a number, then of course we can store this number into our max depth function, or the returning value from the max depth function. Max depth takes the root.left, and another one, you guess it, using the right node, can call max depth using the root.right. And before we are returning 1, then of course we need to compare these two. Let's say we have an uneven branch from the 9 and 20. Since 20 will return, we have 1 right here, and we have also 1 right here. And since 1 and 1 since 20 has the same branch of the left and right is equal heights, then of course we compare these two, and to see which one is the highest value, then of course we inherit this value up to the 20, since 1 is the only winner, and we count the 20 itself by 1, and 1 plus 1 is equals to 2, because from the bottom, after we compare both of the 15 and 7 node, then of course we got the 2 as our right node value to depth, and the 1 depth from the left property of the root from the max depth call. Then we compare both 1 and 2. Since 2 is higher than 1, then of course we are returning 2 as the one with the nominated value, and we add this one with the existing node of the root itself. Then of course we got 3 as, let me type this 3 and then delete this part, and we are returning 3 as our answer, because the root is the final branch that we need to count after all of the recursions from the sub branches. And we, as you already know, that we count the 15 using the left and right property called the max depth function using the left and right property. Then of course it is the same thing, the same treatment as the 9 node, and the same thing also goes to the 7 node. Node of 7, it is also returning both 0, the same as the 9 right here. Then of course we only returning 1 and 15 returning 1. Since 1 is the highest value, then of course we are returning 1 plus 1 is equals to 2, and 20 has the value of 2. Then we are returning 20 to our root, and we are returning 1 from 9 to our root. Since 1 is the lowest value, then of course we are returning 2, and then we add this by the value itself. It is not null, then of course we are returning 3 as our answer. So that way, to implement this, since we already assign this as our left node variable and the right node variable called the function itself, which is recursive, then of course we can return 1 plus using the Math.max and check which one is the highest value in the left node and the right node. And they both left node and right node variable will fight to see which one has the highest value, and after that, if the left node has the value of 1, if the right node has the value of 2, then of course the Math.max will only returning the right node, which is the value of 2. Then the value of 2 will be added by 1, which is the max depth node itself. Since it is not null, then of course we are adding by 1 and we are returning our answer. So let's run this to see if it works, and we have the accepted answer. Let's submit this by using the Control and Enter. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.